Okay, now we're looking at effective rate of interest, which is used to work out which loan is better or which investment is better. So just have a look. We've got two drinks of Coke here. We've got one that's a can for $2.20, and we've got a bottle that's a 2 litre bottle for $5.45. Now, if you try to work out which is the better one, the only way you can kind of do this is to actually work out your dollars per milliliter. So it works out as cents per milliliter or dollars per milliliter, and that will give you the best value. Now what you're doing there is you're converting it down so they are the same thing. So you can compare apples with apples. Now what happens with a loan? What happens if you've got a loan and you're trying to work out what's the best one to do? So or an investment, which is probably even more important when you're trying to put money away. How can you work out the best one? So let's have a look here. You've got a choice of two accounts. You've got a 4.25% compounding monthly or a 4.75 compounding quarterly. How can you compare those two? Because they are different. 4.25 is different from 4.75. This is compounding monthly, this is compounding quarterly. So you haven't got the same base level. Like up here, with our milliliters, we converted them both to milliliters and we can compare them. We've got to be able to convert this to something. And that's called an effective rate of interest. And what that does is it converts your interest rate to an interest rate which is compounded once per year. So it compounds it once per year and it tells you which is the best value. Now that is called an annualized rate. Annualized meaning once a year, or annual is a year. So it's converting your interest rate to an annualized rate, which is as if it is being compounded once per year. Then you can compare them. So let's have a look at how you do it for an investment. Okay, so let's have a look here. If you're investing, which is the better offer? Account A, 4% compounding monthly, or account B, 4.2 compounding quarterly. Notice that compounding quarterly, compounding monthly. So these are completely different now. These are two things that you've got to work out. You can't compare them. You can't say, well, 4.2 is better because investing, because it's higher. So what we have to use the calculator, and this is quite simple. So you'll have your calculator, and once again we're going to go across to TVM, which is our finance bit, and across the bottom here we've got all our functions. We don't want them. We want to come down here. We've got simple interest, and come down here. It says F5 for conversion. So come across to F5, push conversion, and you'll come up with effective rate or appropriate rate. So we want to look at effective rate, EFF, and we've got a value of N and a value of I. The value of N is the number of times per year that it compounds. I is the interest rate. So N, number of times per year it compounds, okay? And I is just the rate. You don't have to do anything with that interest rate. So that's pretty cool. So let's go back to the calculator. Let's try it for this first one. We've got an N of 12 because it compounds monthly, and our I is 4. And all you do is you come down and push F1 for effective rate of interest, and it converts it to 4.07. So the calculator has done that for us. It's taken in the N as 12 and I as 4, gives us 4.07. Let's repeat it for the other side. N is now quarterly, so this is quarterly. So therefore N will become, N will become 4. And then your I is 4.2. And then we want to convert it to an effective rate of interest, F1, and it's 4.27%. And this is 4%, 4.07. So as this is an investment, because it's an investment, we want to get the best value, so we want to get the highest rate. So this one here is our highest rate, 4.27, so therefore that is our better offer. Okay, account B is our better offer at 4.2, or the effective rate is 4.27. Now they have to advertise the effective rate when you actually take a loan out and things like that, or invest money. Okay, it's always written in small print. Let's have a look at what happens if you've got a loan. Loans are slightly different. Loans, you've actually got to do two steps, because some loans have fees and charges in them, and they get added on to how much you've got to repay. So you've got to actually work out how much the loan's going to cost you with all the fees and charges, and then take them out and work out what interest rate would get you to have that. So let's have a look at how you do it. First thing I've got to do is we've got to work out the total paid back. Let's have a look at this question here and we'll go through it. Find the effective rate of interest when you borrow $450,000 over 25 years with monthly repayments and the interest rate is 6.24% per annum compounding monthly. There is a $750 establishment fee and a $9.50 monthly charge. So this is often what happens in a loan. Now, as this is a loan, so it's different from using that other function in the calculator. So what we have to do is we've got to work out how much we pay back. So we've got $450,000 which we borrow, $750 which is the establishment fee, 9.5 is our monthly charge. It's 12 months in a year, and we go for 25 years. You add that, times that up, and add it all together, and you'll get $453,600. So effectively, you're borrowing $453,600 when you take out this loan. So now what we do is we stick it into a PV question because it is a loan question. So we put in 25 times 12, which is our N, 6.24, which comes from the question. PV, our present value, is 453,600 because we get that from here. So that goes into there, 453,600. We don't know what the payment is. We don't know what the future value is. The future value is 0, sorry. Payments per year is 12. Compounding periods per year is 12. So now we just go to our graphic calculator, go back to our money one. We're going to F2 because it's financial, and we put in what we've got. So 12 times 25 is 300. We come down and put 6.24 as our interest rate. Our present value is that whole lot, that 453,600. Oops, that's okay. Oh, okay. 453,600. Payment we don't know. Future value is nothing. Payments per year and compounding periods per year are 12. So we work out payment, which is F4. Okay, we want to work out how much what our payments are. We do that, and we get 2989.46. So our payments are going to be 2989.46. So that's how much our payments are in total to pay back this loan. Okay, so that's not too bad. So that's how much we've got to pay each month for the whole time. Now this number now comes in here for our payment. Okay, so we grab the 2989.46. That becomes our payment. Our future value is 0. Our payments per year are 12, compounding periods per year. And notice that our PV now goes to be 450, because now we're saying if we have to pay back 2989.46 back on the loan, which is actually only for $450,000, what's the interest rate on that? So we want to try to work out what I is. So you've got all your data on the calculator, so just go repeat. You come back into here, and all you do is go 450.123. Your calculator's put in your 2989.46, and if you kind of roll up to here, you've got I there. So all you want to do is calculate I, which is putting F2, hit F2, and you get 6.33. So you have an effective interest rate of 6.33%, even though it's advertised at 6.24 because of the extra fees and charges. So your effective rate is 6.33, and that gives you your rate that you are effectively charged to pay that loan back. So that is how you work out how you would go about finding the effective rate of interest on an investment and an effective rate of interest on a loan.